Today we're going to be talking about Lesson 2 in Chapter 5, Solving Systems of Equations by Substitution. So in order to solve a system of equations by substitution, first we have to solve one of the equations for one of the variables. So we either need to isolate x or y in simply one of the equations. Now, we'll then use that value to substitute the expression from step 1 into the other equation and solve for that variable. We can then substitute the value from step 2 into one of the original equations and solve for the second variable. Now, this probably sounds a little bit confusing, but essentially what we're doing is we're finding one value and we're substituting or replacing it for another. Here in number 1, you can see that we have y equals 2x plus 3 and y equals 5. These are both already solved for y. What we can then do is take one expression and replace the variable with the other one. So we can say that 2x plus 3 equals 5x. So here we have this 2x plus 3 equals 5x. Since we know that y is 2x plus 3, we can replace this second y with this expression. Remember, these are two separate equations and we're trying to find the point of intersection. Now that we have substituted one expression into the second equation, we can solve for the variable. So we're going to start by subtracting 2x from both sides. We're left with 3 equals 3x. To get x by itself, we can divide both sides by 3 to find that x equals 1. Now, we take this value and plug it back into one of my original equations. So if I do this, I have y equals 2x plus 3, and I'm replacing x with 1. 2 times 1 is 2, plus 3 is 5. So I should know that x is 1 and y is 5. Or as an ordered pair, my point of intersection of these two equations is going to be the point 1, 5. Now we can look at the next one. Using the same method, we can see here that y is already isolated. So we can take this expression and replace y in the other equation. So when we do that, we can rewrite 4x plus 2 times 1/2 x minus 5 equals 0. So again, we've replaced y with this expression. 2 times 1/2 x is 1x. And 2 times negative 5 is negative 2.5, or negative 5/2. And we're going to leave it like this simply for graphing purposes here. So 4x plus 1x is 5x minus 5 over 2 equals 0. We can add 5/2 to both sides to find that 5x equals 5 over 2. Now, to solve for x, we can either divide by 5, but since we have a fraction, instead of dividing, we can multiply by the reciprocal. So the reciprocal of 5 is 1/5. So we have x equals 1/2. Now we can plug this back in again to one of these two equations. So I'm going to go ahead and plug it into the first one. So 4 times 1/2, because x is 1/2, plus 2y equals 0. 4 times 1/2 is 2. We can subtract 2 from both sides to find that 2y equals negative 2. Divide by 2 on both sides to find that y equals negative 1. So again, we can have that ordered pair of 1/2, negative 1 for our point of intersection or our solution to the linear equation system. Now go ahead and try number 3 on your own. In number 3, we can see that x is isolated by itself. So we can use this expression and replace x. So we have 2 times 5y plus 3 plus 4y equals negative 1. 2 times 5y is 10y. 2 times 3 is 6 plus 4y equals negative 1. 10y and 4y is 14y. And subtracting 6 from both sides will get us 14y equals negative 7. Same sign, so we add and keep the sign. When we divide by 14 on both sides, we can find that y equals negative 1/2. Again, we can go ahead and use this value to plug into one of the equations to find the solution. So if I plug it back into my first equation here, I have x equals 5 times negative 1/2 plus 3. 5 times negative 1/2 is negative 2.5 plus 3. So x equals 0.5. We would subtract these and keep the sign of the larger number since they have opposite signs. Now, when we write this back out, we don't want a fraction and a decimal. So we either need to change them both to fractions or both to decimals. So here I would change to to fractions, most likely. So 0.5 is 1/2, and then negative 1/2. Now, with 8 and 9, you can see that they are not solved for a single variable. So the first thing that we have to do is solve for a variable. So we're going to start with this first equation. I always like to choose the one that looks simplest or the most simple. So here we're going to have x minus y equals 9. I'm going to decide to solve for x here. So I know that I'm going to have to add y to both sides. So x is equal to y plus 9. Now, I can take this expression and plug it into my second equation. So I'm going to have 2 times y plus 9 plus 5y equals 4. So 2 times y is 2y. 2 times 9 is 18. 2y and 5y make 7y. When we subtract 18 from both sides, we're going to find that 7y equals negative 14. So y equals negative 2. Now again, we can take this value and plug it back into one of the equations. So x minus negative 2 equals 9. Minus a negative is like plus a positive. So here we're going to subtract 2 from both sides. We're going to be left with x equals 7. So our ordered pair here is 7, negative 2. Now remember, if we would plot these two lines on a coordinate plane, this should be the point where those two lines cross or where they meet. Go ahead and try number 9 on your own. On this second one, I used the second equation and solved for y, since it was the only variable with a coefficient of 1. So here to start with, 4x minus y equals 15. Subtract 4x from both sides to find that negative y equals negative 4x plus 15. We can't be left with a negative variable here, so we're going to divide by negative 1. Remember that changes all the signs throughout the equation. So negative 4x divided by negative 1 is 4x. 15 divided by negative 1 is negative 15. Now I'm going to take this expression and plug it into that first equation. So 2x plus 3 times 4x minus 15 equals 25. 3 times 4x is 12x. 3 times negative 15 is negative 45. When we add 2x and 12x, we get 14x. We can add 45 to both sides to find that 14x equals 70. Dividing by 4, we'll find that x is 5. Again, we're going to take this number and plug it into our first equation. And you can really plug it into either one. I just usually go back to my top one, but it needs to be the original one. So 2x plus 3y equals 25 when x is 5. 2 times 5 is 10. When we subtract 10 from both sides, we find that 3y equals 15. So y is 5. So again, our ordered pair here would be 5, 5.